Hello everyone, welcome to Mastermind. In this video, let us continue our discussion on atmospheric circulation and weather systems. Till now, we have discussed part 4, so this is fifth part. So this will be important part of our geography in prelims also and also in the mains. So in the last part, if we have to revise, we were discussing about the forces which affects the velocity and direction of the wind. So in that first one was pressure gradient force. First one was pressure gradient force. Second one which we discussed was frictional force. Frictional force. And third one Coriolis force. Coriolis force. And the fourth one will be pressure. Pressure and wind. We have already discussed about pressure gradient force and frictional force. In this, let us understand what exactly is Coriolis force. Let's start with one example. Let us take a circle. Okay. Now, let us take this particular point. Now, there is a person A over here and there is a person B over here. So now, if A and B have to reach on the other end, then let us say this person has to travel this distance. This person has to travel this distance. Okay, that is B has to travel longer distance. So in a circle, if we are considering a person moving from the very corner, then he will have to travel really long in order to reach the other point, whereas the person who is very close, that particular person will reach in lesser distance. So similarly, we can take the example for Earth also. Similarly, we can take an example for Earth also. In case of Earth, we know that the Earth is rotating from west to east. It rotates in this particular direction, correct? So the Earth rotates, but this particular point, this is poles. This particular point, this is south pole, this is north pole, this is south pole, whereas this particular place is equator, correct? This is Tropic of Cancer, this is Tropic of Capricorn. So it is rotating from west to east. So we know that the Earth completes one rotation in 24 hours. It completes in 24 hours. But to complete that one rotation, the equator has to be faster, correct? It has to rotate faster, and the speed decreases as you go further. Speed decreases as you go further towards pole. When you go towards pole from equator, the speed decreases. That is, let us say there is a person over here, and there is a point or a place over here. There are a few more people over here. Now we know that speed here is more. Comparatively, speed here is less. Again, if you go further, speed is again a little less. Okay, now let us just consider an example that this is turning in let's say 10 km per hour speed. Just an example to understand. This is turning at the speed of 10 km per hour. That is, this rotation is at 10 km per hour. So obviously this particular place has to be a little slower, right? That is, let us say this is rotating at 8 km per hour. Now if this person, let's say, throws a ball towards here, he intends to throw in straight direction only. He intends to throw it straight only. But because this speed is more compared to this speed, So the speed here is less compared to this speed, which is more. What happens is the ball gets deflected to the right side. From here he is throwing, his face is over here, so from here he is throwing, so it goes towards his right hand side, correct? So the ball gets deflected towards this particular place, correct? Because the speed of equator is more compared to the speed of the tropics, so because the earth is in geoid shape, correct? Now let us consider this scenario wherein, let us say, one person XYZ is throwing the ball from equator towards this particular tropics or this particular subtropic. That time this speed is more, this speed is less. So because by that time this person, he intends to throw it like this, but because the speed is more, this gets deflected towards right, direction. Similarly, if that person is throwing in case of southern hemisphere, it gets deflected towards left, why is this? Because the speed differs, and also the size differs, and this difference itself is called as Coriolis effect. Difference is called as Coriolis effect. So if we are looking at this particular image over here, this is showing about the winds, trade winds. There is westerlies, there is again trade winds, then there is again westerlies. So these are different cells. For example, this is 30 degree, this is 30 degree. So the first one is the Hadley cell, and above there is Ferrel cell, etc. So what is happening over here is something which we have to understand. I hope till here you have understood what exactly is Coriolis force. So this Coriolis force is towards right direction if you consider the northern hemisphere, and it is towards left direction if you consider the southern hemisphere. And from the direction you have to decide, okay, if it is north or if it is south. Now let us understand this particular image over here. Why is this direction like this, etc., and all we'll understand. Before that, we will just look into this as earth, and the smaller concept, which is there is a sun over here, which you have seen in previous videos also, and this shines more over here, and because of that the tropics gets heated more, and because of the heat the air becomes lighter and there is lesser pressure and it goes up. Okay, so the air over here, let us consider this as a sun, and it has heated up the air over here. The air, let us say it is present over here, it has heated up. So what happens is air rises up, and because it rises up, the way it goes on top, it collects a lot of moisture. It cannot come down over here only, correct? Because again a lot of air is rising up, because the temperature is same over there, so it cannot come there only, it cannot come down there only. So what happens is the air goes towards this direction, and because it is going towards that direction, here the temperature is relatively less. So compared to this tropic region, the temperature in this particular case is relatively less. In the top it is relatively less. So what happens, it collects a lot of moisture, it has weight, so it comes down, over here, and it cannot go further, so it again flows from higher pressure region to lower pressure region, because we have seen that because of lower pressure only this is rising up, right? And as it went, it collected lot of moisture and the pressure increased. Because the pressure increased, the weight of the air also increased, and because the weight of the air increased, it came down. Again we know that there is low pressure over here, and air moves from high pressure area to low pressure area, but when it is coming like this, there is this deflection because it is coming from this direction. That is what is Coriolis force. Otherwise it had to come like this, correct? It had to come like this. It intends to come from low pressure area, high pressure area to low pressure area in straight direction. But because there is the earth rotation which is happening, and because of the earth rotation there is Coriolis force which is acting, and because of that Coriolis force only, it gets deflected towards its right. So you can see that it is towards this right, because you have to see from this particular angle. You cannot call this as left over here, considering this is equator, because sometimes it might get confusing. It is towards the right of that particular direction. So because of it, the speed of this equator also is more compared to that of that. So as it comes, it goes towards left. Again the same cycle continues. As it comes towards here, then again there is lot of sunlight over here. Then the air warms up. As it warms up, it rises. As it rises, it starts to subside towards here, and it collects lot of moisture. The weight increases. Again it comes down. Similarly, if you are looking at the southern hemisphere, the air has risen over here, and it starts to go towards the it starts to go towards this particular place, which is again subtropics over here. And as it goes, it collects lot of moisture, and it comes down. And then again there is high pressure area over here, and here again there is low pressure area. It has to come towards low pressure area, but it deflects towards its left. And this deflection is called as Coriolis force. So I hope you have understood about Coriolis force. One fact about this Coriolis force is that as you go towards the pole from equator, the Coriolis force increases. That is, the Coriolis force itself is directly proportional to the angle of latitude. So it is maximum at the poles, whereas it is absent at the equator, because we are seeing it in comparison to this. See, this doesn't subside, or this doesn't collide with each other, correct? This doesn't collide with each other. So there is this intertropical convergence zone. There is the convergence zone over here. This doesn't collide with each other. It just continues in its own direction, and then the circulation of the wind from high pressure to low pressure continues. One very important point for prelims is that the Coriolis force at equator is 0. This is the reason there is no tropical cyclones which are formed near the equator. The reason is Coriolis force. Otherwise, cyclone is that rotation of wind and all, right? We'll understand about that in future videos with the help of diagrams. But there is no tropical cyclones. Tropical cyclones are not formed near the equator. So I hope you have understood about the Coriolis force. Last one, what is pressure and wind? The pressure we have seen already, which is related to the gradient. We had seen related to gradient, and also we had seen related to friction. About frictional force, we had seen that as the altitude increases, as you go higher, the frictional force is less, so there is less of friction, and hence there is a free flow. Okay, so the velocity and direction of the wind are the net result of this wind generating force. The wind in the upper atmosphere, which is 2 to 3 kilometers above the surface, are free from frictional effect. They are free from frictional effect because there is hardly any resistance over there. And they are mainly controlled by the pressure gradient and Coriolis force, which we have seen before. Now in the next part, we'll continue in this chapter only. We'll look at what are the general circulation of atmosphere, and what is the latitudinal variation of atmospheric heating, emergence of pressure belts, migration of belts, etc. We'll be looking at, because this is a little huge chapter when it comes to explanation. Because if you are looking at this particular chapter in NCERT, then it is hardly some 4 to 5 pages. But every word in this particular NCERT chapter will also be very important for us in order to understand how things work. Only then the NCERT will be properly complete. So I hope you have understood about the Coriolis force. You have to understand from what direction that it is happening, and then only on the right of that particular direction will be in the northern hemisphere, and on the left will be the southern hemisphere. So I hope you have understood about this particular concept. In the next particular concept, we'll continue with this only, the next particular part. So in the e-paper, there are multiple choice questions for you to answer. You can attempt those. I'll see you soon in the next one. Thank you.